All right, now today we are going to talk about indices. Indices is a separate chapter and it is used in many other chapters. Okay, so first we will discuss indices. Then today we will be talking about a variety of past paper questions that would cover a good number of chapters that we have already discussed. Okay, so this way we would be able to revise the old contents and everything should be clear. Okay, so think about it as a new starting, as a new beginning. Forget about the old contents and everything. This is new and it has nothing to do with the old contents. Okay, let's talk about it first and then we will use this in the past paper questions. All right, okay. So we are going to discuss the laws of indices. All right, this is what we are going to talk about. Okay, before talking about this, let's just talk about the notation. For example, if I have a number a power m, this m is basically the index. It is the power, or you can also call it the exponent. Okay, I'm just talking about the notation. And this number right here is basically the base. So a quick revision, if I talk about b power n, this is the index and this is the base. So in indices, we will be using these terms again and again. Base, power, base, power, base, power. Okay. So I hope this idea is clear. That's simple, it's easy, and it would get even clear when we talk about the questions. Okay. All right. Okay. So law number one. We have multiple laws. Let's just talk about the first one. The first one says a power m multiplied by a power n is going to give you a power m plus n. Now what is happening? We have two bases and both the bases are same. We are multiplying the two numbers, so powers are added. Okay. For example, let's say I have 2 power 6 and it is being multiplied by 2 power 2. So the base is 2 and the base is 2. Both the bases are same. When bases are same, powers are added. It would become 6 plus 2 and it would be 2 power 8. This is the first law. Okay. Let's talk about the second one. Again, the bases are same. We have a power m and it is being divided by a power n. The bases are same and the numbers are being divided. So it would be a power m minus n. It would be a power m minus n. Okay. For example, again, let's talk about 3 power 2 and it is being divided by 3. So if you have nothing in the power, just know that you have 1 in the power. Okay. Now again, the bases are same. Both the numbers are same. Both the numbers are 3. So I can directly just subtract the powers. The two powers are 2 and 1. So it would become 3. Okay. These were some simple laws. Let's talk about the third one. Now, if you have a base and if you have a power and then we have a bracket and then we have another power. So you can multiply both these powers and we can write it as a power mn. For example, if you have 4 power 2 and then you have brackets and then you have 3, you can write it as 4 power 2 multiplied by 3, that is 6. So we have discussed 3 rules so far. For the first one, the bases are same and the numbers are being multiplied, so the powers are added. For the second one, it's division. We are dividing the two numbers, so the powers are subtracted. And for the third one, we have 2 powers and we have a bracket between them, so the powers would be multiplied. Okay, let's talk about the fourth one. The fourth one says A multiplied by B, and it's A power n and it's B power n. This time around the bases are different, but the powers are same. Okay, the bases are different. A and B are two different numbers, but the powers are same. The power is n. So when we will multiply them, we would get A multiplied by B whole power n. For example, if you have 3 squared multiplied by 2 squared, now the two bases are different. So it would be 3 multiplied by 2, that is 6. And we would just write it as 1 power, that is 2. All right. So this was the fourth rule. And let's talk about the fifth one. The fifth one says, again, if you have two different bases and the numbers are being divided and the powers are same, so this time around, we can write it as A by B with 1 power. For example, if you have 3 squared and it's being divided by 2 squared, now the power is same, so I can write it as 3 by 2 whole power 2. All right. Now, these are the 5 most basic rules or laws of indices, and you can make a lot of laws using these. Okay. So the first one is that the bases are same and the powers are different. So we have added them. Bases are same in the second one, and then the powers are different. We have subtracted the powers. Then the powers are multiplied. Then we are writing it as 1 power. Okay. Now, let's talk about a few more rules, and they are also important. All right, let's talk about the sixth one. The sixth one says A power 0 is 1. This basically means if you have a number, let's say the number is 2, 2 power 0 is going to give you 1. 3 power 0 is going to give you 1. And why exactly is it 1? So one of you asked this question earlier, and now we can discuss this. It's 1 because if I write it this way, 2 divided by 2. Now we do not have anything in power, so imagine it's 1. I can write it as 2 power 1 minus 1 because the bases are same and the two numbers are divided, so the powers would be subtracted, and this would give you 2 power 0. And you know that when you do 2 divided by 2, it gives you 1, right? That is why in general it is a rule, any power 0 is 1. Okay, any power 0 is 1. All right, any confusion so far? Anything that you were not able to understand? All the students, please confirm.
Ma'am, I did not understand after the second part.
Say it like this one.
नहीं मैम इससे ऊपर वाला.
This
Yes, ma'am. I
rule,
did not.
this rule, right? This
Yes.
rule in general. Okay.
Yes. Yes.
All right. Okay, I'll tell you. Okay. So the rule says that if you have any number, it could be 1, 2, 3, 4, 5, 6. It could be a negative number as well. If you have any number power 0, the value is going to be 1. Okay. For example,
Okay.
let me just state a few examples and then we'll talk about that. Why is it 1? For all values of A except A equals 0. Now it says A power 0 is 1 for all values of A except A equals 0. This means 3 power 0 is 1. This would mean 10 power 0 is 1. This would mean 1 by 2 power 0 is 1. This would mean negative 1 power 0 is going to give you 1, right? All values of a except a equals 0. So if you have any number 0 0.1, 0 0.2, 1 by 2, 1 by 3, 2 by 6, any number power 0, the mathematical value is going to be 1. Okay, any number power 0 is 1. Okay, is it okay now?
Okay,
It's a
ma'am.
rule. Very good. Okay.
Yes, yes, I understood.
Okay, perfect. And why is it 1? Let's just quickly talk about it. So we know that if we have 3 divided by 3, I can think about it as 3 power 1, 3 power 1. I know that 3 divided by 3 gives me 1, okay? But how do I write it? If I use the laws of indices, it would be 3 power 1 minus 1, because the bases are same and we are dividing the two numbers, so the powers would be subtracted and it would become 3 power 0. And I know that 3 divided by 3 is basically going to give me 1. So this is the idea behind it, but if you were not able to understand this, just consider it as a law. If you have any number with 0 as its power, it is going to be 1. Okay, this was the sixth law. All right, let me
Okay, ma'am.
just, perfect. Let me just erase this. Okay, let's talk about the seventh one now. Okay, the seventh one is basically for negative indices, or you can think about it as negative power. It says a power negative n is basically equal to 1 by a power n. And you can also think about it as, if you have 1 by a power minus n, you can write it as a power n. I'll explain this, don't worry. What's happening? This rule is about the negative power. If you have negative power for any number, if the number is a numerator, just move that to the denominator and you can write the number with a positive power. If the number with negative power was in the denominator, you can write the number in numerator with positive power. For example, if I have 3 power minus 2, I can write it as 1 by 3 power 2. And this would give me 1 by 9. For example, if I have 1 by 2 power minus 3, I can take this 2 power minus 3 to the numerator just so I have the positive power, and it would become 2 power positive 3, that is 8. Then if I have, let's say 4 power minus 2, I can write it as 1 by 4 power 2 and it would give me 1 by 16. Okay. And if I talk about another example that is technical. So you can think about it as if you have 3 power
I understand.
minus 2 divided by 2 power minus 4. Okay, let's say this is the question. In order to simplify this, if the calculators are allowed, then fair enough. By all means, you can use your calculator. But we will be talking about past paper questions in some time, and there you will see the examiner would ask you such questions in paper 1 where calculators would not be allowed. So what do we know? It's negative power. It's very simple. We know that I can take it to the denominator. It's negative power, so I'll take it to the numerator. Okay, so it would become 2 power 4 divided by 3 power square, and then you can just simplify it. For now, we know if we have a number with negative power, in order to write it down with a positive power, just relocate the number. If it's a numerator, take it to the denominator. If it's in the denominator, take it to the numerator. Any confusions with this? Please tell me if you were able to understand this or not.
Yes, ma'am, I've understood.
Okay, very good.
I
And
understand.
okay,
I
Urva?
understand.
Okay, all right. Very good. And Urva, what about you? Yes, Urva, is it okay? Urva, are you there? Okay, all right. So this was basically the seventh rule. And then we have two more rules, and then that is it. We would be in the position to talk about the some examples first and then past paper questions. Okay. All right. So this was basically the seventh one. We have two more. Let's talk about the eighth rule. The eighth rule is for fractional indices. So if you have a power 1 by n, you can think about it this way. Okay. For example, we have been talking about the cube roots and the square roots. Okay. So if I talk about the cube root of a number, let's say the number is a, and I'm talking about its cube root, I can write it as a power 1 by 3. If I talk about the square root of another number, I can write it as b power 1 by 2. If I talk about the fourth root, now we have not discussed fourth roots, and the examiner would not ask you for the fourth root, but just for the understanding, the fourth root of a number, let's say c, can be written as c power 1 by 4. So whenever you have a fractional power, a fractional index, think about it as the third root, as the square root, as the fourth root, as the nth root of the number. Okay. Best way of understanding this would be if we consider an example. Let's say you have been asked to find the cube root of 8. So we know that 8 can be written as 2 power 3 and cube root can be written as 1 by 3. Now, what do we know? We have discussed this rule already. Let me just scroll up and let me just go to that rule. The rule was whenever we will be having a power and then another power, the two powers would be multiplied. Let's just multiply the two powers. We will multiply 3 and 1 by 3. So these two would be cancelled and we would be left with 1. That is why the answer is 2. If I talk about the square root of 4, I can write down 4 as 2 power 2, and I can write down the square root as 1 by 2, and now I can cancel the powers and I would be left with 2. Okay. So this is basically an understanding about the fractional index. Yes. Any confusion with this?
No, ma'am.
All right. Perfect. And then just one last rule. It's important. It says if we have a number a with power m by n, you can think about it as, now m is basically the power of that number and n is basically the nth root. Okay. We have discussed a similar example above. Here we had 1 by n, so we wrote a power 1 with the nth root. If you have a fractional index where the numerator is m and the denominator is n, the numerator would basically be the power of that number and the denominator would basically be the root. Okay, this would get there. Let's talk about 2 to 3 examples over here and you would understand the idea. All right. Example number 1. Let's say you have 2 power 2 by 3. So you need to understand it this way. It's the cube root of 2 power 2. Example number 2. Let's say you have 3 power 4 by 3. So it is the cube root of 3 power 4. Let's say we have 2 power 1 by 2. So it is the square root of 2 power 1. Okay. Then one last example. Let's say you
can you repeat it?
Yes, I am repeating it. Don't worry. Imagine you have a number. The number is 8. The power of 8 is a fraction. Let's say 2 by 3. The numerator of the fraction would become the power and the 3 would basically become the root. So it would be cube root. Here we had 2 by 3. So 2 became the power and 3 was basically the cube root. Here we had 4 by 3. 4 was the power and 3 was the cube root. 1 by 2, 1 was the power of 2 and 2 was basically the square root. 2 by 3, the 3 in denominator would basically come over here and the 2 in numerator came here as the power. Understood?
Yes, ma'am.
And what about Urva, Taha and Muiz?
Understood. Ma'am, I understood.
Okay, Urva, are you there? All right, okay. So let's talk about some examples and then we need to quickly shift to past paper questions. All right, so let me write down some examples. Okay, example number 1 says 5 power 18 is divided by 125. Okay, this is the question you need to simplify. Okay, we need to simplify this. In order to simplify this, first of all, I know I need to write down 125 as the power of 5. Okay, so we know that 5 multiplied by 5 is 25, and then if I multiply 25 by 5, that would give me 125. So 5 multiplied by 5 multiplied by 5 gives me 125. This means that it is 5 cubed. Okay, so I can write down the same question as 5 power 18 divided by 5 power 3. Now I have two numbers and the two numbers are same. The bases are same. I have the division sign. So I can write it as one base and I can just subtract the powers and it would become 5 power 15. All right.
Understood.
Okay, very good. This was the first question. Let's talk about the second one. The second question says we have to again simplify 3 divided by 6 multiplied by p power minus 4. Now this is the question and we need to simplify it. This is what the examiner wants. So I'll write it down this way. This can be written as 3 divided by 6 multiplied by p power minus 4. I can cancel 3 and 6. It's 1 times and it's 2 times. Now I have 1 divided by 2 multiplied by p power minus 4. I need to simplify, so I'll just take this to the numerator just so I have p with the positive power and I would be able to write it as p power positive 4 divided by 2. This is going to be the answer. Yes. Any confusions with this?
No, ma'am.
All right.
Can
Yes.
you repeat it one more?
Definitely. I definitely repeat it. This was the question. So I wrote 3 divided by 6 multiplied by p power minus 4. 3 and 6 were cancelled. I was left with 1 by 2 into p power minus 4. The question was to simplify. Everything was simplified. The only thing I was left was I had to take this p power minus 4 to the numerator just so I can write down p with a positive power. Okay, so we know this rule. Negative index, the number can be relocated and the power becomes positive. So this is the answer. Okay.
Okay, ma'am.
Understood.
All right. Okay. Very good. Okay. Let's talk about one last example and then past paper questions. This is very, very important. And it is example number 3. It says 3 multiplied by y squared divided by 5x, then division sign, and then 3x squared into y divided by 20xy. Simplify this and express your answer in positive index. So you need to simplify and write down the answer with positive index. Okay, that's already how we simplify expressions. All right, now this is the question. So first of all, I need to rewrite it. Now I have two fractions, and between these two fractions I have division sign. So what do I know? I'm talking about the solution. I'll write down 3 power y squared divided by 5x. I'll change the division sign to multiplication, and I will take the reciprocal of this fraction. Okay, this is how we deal with fractions, right? So this would become 20xy divided by 3x squared y. I repeat, the red is the question. I need to simplify. Whenever we have two fractions with a division sign between them, how do I simplify them? I convert the division sign to multiplication, and I need to take the reciprocal of the second fraction. When I say the reciprocal of the second fraction, I need to shift this to the denominator and this to the numerator. Okay, this is how we usually deal with fractions which are coming with a division sign. Next, I need to cancel out things. So x and x can be cancelled, they are same. Y and y can be cancelled. 3 and 3 can be cancelled, and we are left with 20 y squared divided by 5x squared. All right, then it's 1 times 5, it's 4 times 20. So this would be 4y squared divided by x squared. And finally, we can simplify it further and write it as 4 multiplied by y by x with 1 power, because we can see that both the powers are same. So we can write it down this way. So I'll explain this again, and then if you're not able to understand, I will repeat. Okay. This was the question, the one written in red. It had a division sign. Always remember, we convert the division sign to multiplication. And obviously in maths, you can't do anything of your choice. You can't say if it's division, so I'll write down multiplication. No, you can do anything until and unless you are balancing it. The division sign is converted to multiplication. And in order to balance this change, we are taking the reciprocal of the second fraction. So the reciprocal of the second fraction basically gave you 20xy in denominator and 3x squared y in denominator. Okay, 20xy numerator and 3x squared y in the denominator. Then 3 and 3 were cancelled, x and x were cancelled, y and y were cancelled, and we were left with 20 y squared. Please keep your mics muted. And it would be divided by x squared. Okay, and after simplifying, we got 4 into y by x whole squared. Okay, this was the answer. Yes, any confusions with this?
No, ma'am.
Taha, Moiz, and Urva, please confirm if you were able to understand this or not.
Yes.
All right, okay, that's perfect. Now I am going to shift to the past paper questions. Okay, and here we will basically be discussing a variety. All right, okay, so this is paper 1, and in the beginning of paper 1, this thing would clearly be mentioned: electronic calculators must not be used in this paper. Okay, so what is happening in the first question? Now, in the first question, we have two fractions, 2 by 7 and 1 by 5, and they're coming with a plus sign. So I told you, whenever we have two fractions and whenever we have plus or minus sign between the two fractions, we are going to take the LCM. Okay, So the LCM of 7 and 5 is going to be, let's take that and see. It's 7 and it's 5. So we'll take 7 first. This would become 1. This is 5. We'll take 5, 1 and 1. And the LCM would be 7 multiplied by 5, that is 35. So it would be 35. Now, the LCM is 35. So I need to multiply 7 by 5 in order to get 35. So I will be multiplying 2 by 5. It would give me 10 plus 5 would be multiplied by 7 in order to get 35. So I would multiply this 1 by 7 as well, and it would give me 7. And the final answer is going to be 10 plus 7, that is 17 divided by 35. We have discussed fractions, and we can have 4 signs between two fractions. It could be plus or minus. It could be multiplication division. Whenever we have plus minus, you need to take the LCM. The LCM was 35. I've written 35 here. 7 would be multiplied by 5 in order to have 35. So I've multiplied 5 with the numerator of that was 2. 2 multiplied by 5 gave me 10. And then we have 5. 5 multiplied by 7 would give you 35. So 1 was multiplied by 7 and it gave me 7. So 10 plus 7 is 17 divided by 35, and this would be the answer. Okay. If I talk about the next one, again we have two fractions. This is one fraction, this is another fraction, but the other fraction is written as a mixed number, and we have multiplication sign. So first of all, I'll write down the first fraction, multiplication sign, and let's just convert 1 whole 1 by 5 to a fraction. So how do we do that? 1 would be multiplied by 5 and the answer would be added in 1. Okay, 1 multiplied by 5 gives you 5 plus 1 divided by 5. So in general, I can write it as 6 by 5. 1 whole 1 by 5 was a mixed number, and I can convert this mixed number to a fraction, that would be 6 by 5. And now it's multiplication. So in multiplication, it's very simple. I can multiply the numerator with numerator, and I can multiply the denominator with denominator, and it would give me 12 divided by 25. So this is going to be the answer. Yes. Any confusions with the first two questions? Please tell me.
No, ma'am.
All right. Okay. Very well done. The second question. The second question is about percentages. Write 17 whole 1 by 2% as a fraction in its simplest form. Okay. First of all, I need to convert 17 whole 1 by 2 to a fraction. So how do we do? 17 would be multiplied by 2. Calculator would not be allowed, so you need to do it separately. 17 multiplied by 2 would give you 34, and 34 plus 1 is 35 divided by 2. So we have 35 divided by 2%. Okay. Now I can write it as 35 divided by 2. Percent means I need to divide that number by 100. Okay. Percent is basically per and then cent. Per is divide, cent is 100. So 35 by 2 would be divided by 100. So I can write it down this way. And the next part of the question says, give the answer in its simplest form. So I need to simplify. 5 multiplied by 7 is 35. And then you need to know that 5 multiplied by 20 is 100. Okay. So this would give you 21 divided by 40. This is going to be the answer. I'll repeat this one, don't worry. Here, this was the question. This is written as a percentage and you need to write it down as a fraction. The method is fixed. Okay. First challenge was converting 17 whole 1 by 2 to a fraction. And we know that Mixed numbers are converted this way. We multiply this number with this number and we add it in the numerator. It would become 35 by 2. 35 by 2% means 35 by 2 divided by 100. Okay, so when you will do 35 by 2 divided by 100, this is what you will get. And after just cancelling out everything, this is 1 second, this is 7 by 40. This would be 7 by 40. This is going to be the answer. Yes, any doubts, anything that you were not able to understand, all the students? This is the
No,
correct
ma'am.
answer.
Everything.
Okay, Kabir and Urva, please confirm.
Ma'am, everything is clear.
All right, okay. So it's perfect, okay? So we are discussing questions from whatever we have discussed so far. We did a lot of questions from the chapter of sets. So I would just take a test from it now, but the other topics are important. That is why I'm going through a variety of questions, okay? The second part of this question is basically what we discussed yesterday. We discussed BOD mass, okay? It says evaluate 6 plus 4 into 1 minus 0.4. Okay. Now, the word was BOD mass. Brackets. We need to solve the bracket content first. So it would be 6 plus 4 into 1 minus 0.4 would give you 0.6. And now we have 6 plus 4 multiplied by 0.6. So how do we do decimal multiplications? What is 4 multiplied by 6? 4 multiplied by 6 is 24. And we just have one decimal place. So we would just write down this number over here. Now it is 6 plus 2.4. Please keep your mics muted. It is going to be 8.4. So the answer would be 8.4. Yes, that is the correct answer. Okay. So again, this was a simple question. First, we simplified the brackets. This gave me 0.6. Now I need to multiply 4 with 0.6 before adding, because multiplication comes first. 4 multiplied by 0.6. 0.6 is a decimal number. 4 multiplied by 6 would give you 24. We have one decimal place, so we have just written down the decimal after 2. And 6 plus 2.4 would give you 8.4. Any confusions with this part?
No, ma'am.
No confusion.
Okay, all right. Okay, then we have some more questions. 1 second. Before doing these, let me just do the one. Okay, this one. Let's discuss this one because we have just discussed indices. Okay, now this is basically not only from indices. Indices is used in other chapters. Okay, so here it is about the standard form. Express this in standard form. Okay, all right. So first of all, I'll write it down as 0.043 is multiplied by 10 squared, 100 squared. So 100 squared means 100 multiplied by 100. I can write it as 0.043 multiplied by 100 multiplied by 100 would give you 10,000. Now this is the decimal. We have 1, 2, 3, 4 zeros. So I can move the decimal 4 units to the right. 1, 2, 3, 4. So it would become 430. This would be the new number. And now you need to write it down in standard form. So this is your decimal. Just shift this decimal 2 units to the left. 1 unit and then another unit. And it would become 4.3 multiplied by 10 power 2. So I'll tell you the best way of solving such questions, okay? First of all, just write it down as a simple number, as an ordinary number. It was 100 square. 100 square means 100 multiplied by 100, so it would be 10,000. Now we had 0 043 and it was being multiplied by 10,000. 10,000 has 4 zeros. So I need to move this decimal 4 units to the right. So this would become 430 and you had to give the final answer in standard form. So 430 can be written as 4.3 multiplied by 10 power 2. So it would be 4.3 multiplied by 10 power 2. This was a decimal and I've moved the decimal 2 units to the left. So it would become 4.3 multiplied by 10 power 2. Any confusion, anything that's bothering you? If you're finding it confusing,
No.
please tell me. Okay.
No confusion.
All right. Kabir and Urva. All right. Okay. And then we have one last question. It says, evaluate 1.2 multiplied by 10 power 7 divided by 2 multiplied by 10 power minus 3, giving your answer in standard form. Now, one thing is certain, this question is coming in paper 1. You do not have your calculators. You need to do it on your own. How do we do it? Okay. First of all, I'll write it down this way. 1.2 is divided by 2. And then I'm just separating the 10 stuff over there. It's 10 power 7 and it's 10 power minus 3. I've separated it on the other side. Now, without calculator, 1.2 divided by 2 would be difficult. So I can convert 1.2 to 12 by moving this decimal 1 unit to the right, and it would become 12 power 10 power minus 1. Okay. I've moved the decimal 1 unit to the right. And now the number is 12 into 10 power minus 1. And now it is being divided by 2. And it's being multiplied by 10 power 7 divided by 10 power minus 3. Okay. All right. It's easy. It's 1 times and it's 6 times. So this is 6 and 6 is being multiplied by 10 power 7. I can just take this 10 power minus 1 to the denominator because I want the power of 10 to be positive. So I can write it as 10 power 1 and I can take this to the numerator because the power is negative and I can write it as 10 power 3. Now what is happening? 6 would come as it is. When the bases are same, powers are added, it would become 10 power 10 and it is being divided by 10 power 1. Again, the bases are same, so powers can be subtracted. So I can write it as 6 multiplied by 10 power 9. So this would be the final answer. Let me explain this one last time and then that is it. Okay. Now this was the question. And apparently the question looked a bit complicated, but we know how to simplify it. So I've separated the tens on one side and I've separated the other numbers on the other side. 1.2 divided by 2 without calculator is difficult. We don't know how to do it. So I've written 1.2 as 12 multiplied by 10 power minus 1. And it was being divided by 2. So I've just cancelled this 2 and this 12 and it gave me 6. Next, I'm only left with tens. I've taken 10 power minus 1 to the denominator and I've taken 10 power minus 3 to the numerator, and this was the final thing. Now the bases are same here and here. So the powers would be added. 7 plus 3 would give me 10. So 10 power 10 was being divided by 10 power 1. Again, the bases are same and the two numbers are being divided. So I can subtract the powers. 10 minus 1 would give me 9. So this is going to be the final answer, and this is in the standard form. We can't see decimal. It means decimal is over here, and if the decimal is after the first digit, the number is certainly in the standard form. Okay, so this is going to be the answer. Yes, any confusions?
No confusion.
All right, what about you, Taha? So,
No confusion.
all right, okay, okay. So I hope it's clear then. I'll stop the recording.